Hey guys, my name is Marek and welcome to my channel. Today we're going to be talking about vector databases in AI, and in this video we will break down core concepts like vector embeddings and vector search. Then we go through technical details, distance metrics in vector search and vector indexes, and in the end we will create a real example with Subabase vector store and with question and answer chain to give you understanding and show you how it actually works in a real life. Okay, so let's go. So if you wondered how AI can instantly recommend songs, summarize articles, or find similar images, it's all about vector databases, the backbone of modern AI search and retrieval. So what is vector database? A vector database stores, indexes, and retrieves both structured and unstructured data, such as text or images, alongside with vector embeddings, which are numerical representation of the data. So this enables fast and scalable similarity search, allowing users to quickly find related objects in production environments. So you might ask, like, what is the problem with the traditional databases? Like, these SQL databases match keywords, not meaning. They rely on exact matches when retrieving information. So this means they search for precise keywords, characters, or values within structured data fields. So for example, if you search for smartphone, a SQL database will return records that contains the exact word smartphone, but will not recognize related terms like mobile phone or cell phone. So this keyword-based approach lacks semantic understanding, meaning it does not consider the context, relationships, or meaning behind the words. So as a result, traditional databases are not well suited for tasks that require similarity-based retrieval, such as searching for images, recommendations, or natural language queries. So that's why we need a system that understands similarity instead of just matching exact values. So how does vector databases actually work? So they use something called vector search to retrieve data efficiently. They rely on vector embeddings, which are numerical representation of human readable data like text, images, audio, and video. To enable fast and scalable retrieval, vector databases also leverage something called vector indexing, optimizing searches across large datasets. So what are the vector embeddings, right? So you can think of it as the AI brainpower representing unstructured data. So when we think of data, we often imagine nicely arranged numbers in spreadsheets. This is structured data which fits easily into tables. However, nearly 80% of today's data is unstructured, including texts, images, text, documents, social media posts, emails, and time series data like audio, sensor readings, and video. So unlike structured data, unstructured data is difficult to organize and retrieve effectively or efficiently. We can now transform unstructured data into high-dimensional numerical representations called vector embeddings without losing their meaning. A vector embedding is simply a series of numbers that capture essential features of a data object. Because AI doesn't understand raw text or images, it converts them into vector embeddings. And these embeddings capture meaning instead of just raw words. So for example, if you traditionally search for a word dog, it will only return exact match, a dog, right? So an AI search with vectors, searching for a dog might return something like golden retriever, puppy, or wolf, because they share similar embeddings. Each embedding model operates within a specific vector space, which can have anywhere from 10 to thousands of dimensions. Like, high dimensional spaces allow for more precise representation. Just like colors can be represented in different formats, text or images can also be embedded differently based on the chosen AI model. So how embeddings capture meaning? So vector embeddings encode the semantic relationships between objects, allowing similar items to cluster together. For example, in a word embedding space, words like dog and wolf appear close together since they are closely related, whereas words like apple and banana from a separate cluster further from the animal-related terms. So let me show you actually the example. So this is the visual representation of the vector database, and as you can see, if we click something like, if we're looking for a lipstick, for example, here, it will take us somewhere down here. and it is around, the cluster is around cosmetics, perfumes and care, health and beauty, right? Services and beauty field, so it's in here. So now if we go to something else like bread and butter, for example, it goes to the different cluster, and it's around bread and pastries, meal gastronomy, etc., etc. So when finding a similar, how finding similar objects in AI is done by vector search, right? So vector embeddings enable us to locate and retrieve similar objects by identifying those that are closest to each other in vector space. This process is known as vector search, similarity search, or semantic search, right? So just as we can find words related to dog in a word embedding space, we can retrieve similar vectors for any search query. For example, if we search for the word kitten, an AI system can generate a query vector for it and find its nearest neighbor, such as cat, based on contextual similarity. So why vector search is powerful? Unlike keyword-based search, which relies on exact word matches, vector search understands meaning and context. This allows it to return relevant results even when there are typos, synonyms, or different phrasing, making searches feel more human-like and intuitive. By leveraging vector search, AI systems can go beyond simple text matching and deliver more intelligent, intent-driven results. So, and in the end, we have something called vector indexing. So optimizing search with approximate nearest neighbor. So vector indexing is that process of structuring vector embeddings to enable fast and efficient retrieval of similar data. So instead of checking every single vector, approximate nearest neighbor pre-computes relationships between embeddings, grouping similar vectors together in these clusters, as I've been showing to you. And this way, when searching for a match, the system only looks in relevant region of the dataset, and that significantly improves speed, right? So for example, if you search for this kitten, approximate nearest neighbor could first look within an animals cluster, and then instead of scanning of the entire database, so including unrelated categories like fruits, vehicles. So this targeted approach drastically reduces unnecessary computations. By leveraging this technique, and AI systems can deliver then faster, smarter, and more scalable search experiences. So I hope this gives you like the better understanding how vector databases are operating and how they work. And now I would like to show you the real example to build it up live and to show you how we can actually create our own vector store and parse or store the vectors from our PDF documents. So let's go and let's do it. So I'm using this platform called N8N, and we will be creating a simple workflow and then interact with it. So as a start, what we're going to do, or what we need, is actually to get from my Google Drive Bitcoin PDF. This is just a white paper of the Bitcoin. So it's just like a simple 9 pages long PDF. And we need to get it first into our platform. So what are we going to do and how to do that? We're going to start with our trigger, and then trigger is going to be manual. So that's that. And then from that, we need to find something like Drive. Yeah, so we need to find the Google Drive here. And what we need is that we need to download file, okay? So I have my Google Drive account in here. It's a file download, and from list, it should be loading. Okay, it's here. Let's go. All right, I can save it. And let's test it actually if it's working. So let's test the step. Okay, there we go. So output it our Bitcoin PDF. We can take a look. Okay, great. So it's here, and we have the PDF in here. Okay, great. So we have it. Now what we need, we actually need to connect our vector store or vector database. So let's just go and start doing that. We are going to be using the Subabase vector store for this example. What we need to do right now is just we need to add documents to this vector store, right? So we're gonna check it out. I created my Subabase account again, so I'm not going to go through it. And now we are inserting documents, and we are actually inserting documents. Okay, so this is just the table in our Subabase. So let me just quickly show you. In my Subabase account, I created my vector store, and I created the documents table. As you can see, it's empty and is waiting for its vectors to be filled in. So let's try that. For this case, we also need to add option. We will be matching documents. That is just fine, and we can hit save. Now the next steps, we need to add the embeddings and the document. Okay, so document loader, I mean. So let's go and do the embedding. So I'm using the OpenAI instance, so I'm going to use that. So we are having these small, that is just fine. OpenAI account we have. I think this is just okay. I think that will be fine there. And we need to load the document right now. So we are going to use the default data loader. Now we have two options. We can use JSON or binary. So I'm choosing binary because we want to be able to add any type of file, right? So I think load all input, automatically detect by meme, that's fine because this will allows us to gather any type of file automatically. I think this is okay. Now to this data loader, we also need to add something called like a text splitter. So this text splitter, it can be like, let's say 3 ways, token splitter, characters text splitter, but I think I'm gonna go with the recursive character splitter for now. And here we have to actually check it out, the chunk size of how we want our vectors to be chunked out. But I mean, for this case, 1000 is fine. You can just play with it and just look for the correct size of your document, depending on how big document is and what's the use case. But I think we are just gonna go something like that, and it should be fine. Okay, so let's hit save and let's check it out if this is working. Let me zoom out. So let's test the step. Let's see if that is going to work. Everything seems all right. All right, great. So we have 30 items. Perfect. And now this is our vectors. Okay, so we have our vector store in our vector database. So as you can see, this is all vectorized right now, and we can verify that in our Subabase account. Boom, and it's here. All right, so it's created 60 vectors. Oh. Yeah, I tested it before, and that's why it's giving this order. But actually, it's okay. There's no worries about that. Fine. So we have this, and what we actually achieved in here, we have our own vector store filled with data from the PDF we actually give it to. So this is our vectorized vector store, vector database. So we can have it, and we can just do something else with it, which is going to be the next step. So the next step could be something like a chat interaction with it. So that means that I would like to have like a question and answer chain to it, and we will be accessing it via chat. Okay, so let's start with that. What we can do here is we can go something like check trigger. Yeah, all right. So we're going to go in here, and then in here we are going to add something called like a question and answer chain, something like that. Okay, so this. All right, so I think this is set up just all right. We're going to have that and save it. Now, what we need to do, we need to add our model. So again, I'm using, you can add whatever model you like, but I'm having my OpenAI chat model. This is because I'm using OpenAI instance right now. So let's go. So it has my account. I'm choosing this for Mini, that is just well enough. So let's go with that. Now what we need to do, we need to create the retriever, okay? So we're gonna go and start that. What we need to do, we need to add this vector store retriever to get our data. So we have a limit 4, I think, which is well enough. Then we're going to add our vector store, which is also Subabase vector store again. And we are actually having our account, we are retrieving documents, great. And we are retrieving it for documents in here. And we need to add our query name to it so it actually matches the documents. So that's cool. We have this, And now we need to lastly add the embeddings again. Okay, again, OpenAI. So we're choosing small, that's that. My account is cool. All right, so I think this is very well done. So now how to test it? We are going to actually test it via our chat window in here. So let's go there. All right, so I'm just going to ask it some question, and let's see how it's going to respond to it. So if we're gonna go and check out the Bitcoin document again, so it's a white paper, so we need to ask it something which is in here. So let's say there is like a peer-to-peer. Okay, so let's ask him about the peer-to-peer. Okay, so what is a peer-to-peer in Bitcoin? Okay, let's check it out. All right, and it gives us the answer. So in Bitcoin, a peer-to-peer network refers to a structure where a participant nodes connect directly with each other to share verified transactions without relying on a centralized authority or intermediary. All right, great. So I mean, this is great. So and if we just go and check it out, if this sentence is in our PDF, I believe it will be not. Yeah, it's not there. But because it actually created this website, it created the response and to summarize that from the vector store, but it actually gives its own OpenAI chat model ability. But actually, it gives us only data based on the vector store itself. That means that if we ask him something which is not there, he will not answer that question because he has no data back. So he's not like making things up or hallucinating or whatever. So if we check it out, for example, in here, because there is something called Genesis block, and this Genesis block is the first block on Bitcoin. So that means that we can check it out. Genesis is not here. Okay, so in this paper. So I'm gonna ask him now, what is Genesis block? And he should not be able to answer. Okay, I don't know. So that's great, because in this PDF, as we said, there is nothing about Genesis block, so that means he cannot answer that, which is great. So now maybe one more test. Let's do that. So let's talk about something. Okay, we can talk about timestamp server. All right, let's ask him about timestamp server. Okay, can you explain me what is timestamp server, please? And he should be able to answer us. All right, beautiful. A timestamp server is a system that takes a hash of a block of data and widely publishes that hash to provide proof that the data exists at a specific time. All right, great. So if we take this sentence again and check it out, if it is here, let's check it out. No, it's not. Okay, so great. So I think this is the very good example of how can we work in a chat with the vector database. And there is I believe millions of applications of that. So in the next videos, I will be actually building live AI agents, because even from this there can be AI agent build, and there will be many more examples I would like to go through. So thank you for watching, and see you there.